everybody. Uh, I'm Sonali Tamankar. I'm a senior clinical data scientist at Fred Hutchinson Cancer Center. Our topic today is simple and practical NLP applications in healthcare. This is an amazing time to be working in this field. Literally every day there is new stuff coming out in terms of NLP and especially generative AI. The point I want to make today is, yes, let's use all these new and shiny and amazing and powerful tools that are coming out every day. And let us also continue to use the humble and not so glamorous, simple tools when appropriate. Let's start with some context. So I work at Fred Hutch Cancer Center in Seattle. We serve over 50,000 patients. We offer clinical trials and cancer screenings. We have over 5,000 employees and 3 Nobel laureates call Fred Hutch home. Until last year, this used to be 2 separate entities. The patient-facing piece was Seattle Cancer Care Alliance, which is where I started, and the research center was separate. Last year, we merged to form Fred Hutch Cancer Center. I sit within the enterprise analytics branch at Fred Hutch. The research people, they are supported by their respective lab resources. So you will find research analysts or postdocs or data scientists doing similar kind of work on the research side. On the care delivery side, analytics support for operational, strategic, and clinical initiatives is provided by enterprise analytics. And this is under the quality improvement umbrella. Our team builds dashboards for tracking KPIs, for looking at clinical outcomes, and so on. The tools our team typically uses is SQL and Tableau to build these dashboards. Our EHR, the electronic health record, is Epic. And we have people on our team with deep expertise in Epic and also an educator who helps clinicians build self-serve tools using Epic provided reporting tools. We do have clinical notes in our SQL data mart. And sometimes when data is not available in a structured format, these can be mined. This unstructured source can be mined for information. I'm the only data scientist on the team, so typically this falls within my purview. Our business partner bandwidth can often be severely limited because these are often clinical people who are providing care. So it's a relatively resource-constrained environment, and simple and practical applications are sometimes what works best. So this is the data scientist philosophy, right? Like in a resource-constrained environment, we want to optimize the outcomes and our productivity. So let's start with first project. This is in the context of breast cancer. SEER program, as they say, even though we think of cancer as a single condition, it actually consists of more than 100 different diseases. So we might think of cancer in the sense that there is uncontrolled growth and spread of abnormal cells. However, each individual cancer, depending on the organ of origin, can behave very differently. So the breast cancer is different from pancreatic cancer, is different from lung cancer, and so on. Even in breast cancer, it is important to know a patient's ER/PR HER2 status. So these are estrogen receptor and progesterone receptor and the human epidermal growth factor receptor. So I'm not a clinician, but to my understanding, what this means is that the cancer cells have receptors on the surface that estrogen can bind to. For example, when a patient is ER positive, that's what it means. And when estrogen binds to these receptors, that can signal the cell to grow and to multiply. So just even at this rudimentary level, we can understand that there is an opportunity to intervene here, right? Somehow, if we can disrupt this flow, then there may be a way to slow down the growth of cancer. So that is kind of how it works. There are targeted therapies. So depending on the type of cancer, that has implications for treatment as well as prognosis. So this project was to extract patient-level genetics information from clinical notes so that we can understand our overall patient panel better for resource planning and care delivery. So this is an example of the resource-constrained environment because, to my understanding, the EPIC EHR does provide a way to document cancer type and stage in a discrete field. However, the provider bandwidth is often so limited that it is not implemented in a lot of organizations. So then it is possible to just go into the clinical notes where this information is present and to extract it. So the simple and practical, keeping with that theme, that the tools that I used for this was the simplest possible tools. I simply used string matching here. So to explain what is triple negative, when we are looking at the ER, PR, and HER2, if a patient has negative in all three, so a patient is ER negative, PR negative, and HER2 negative, they are called triple negative. And there is special interest in knowing this population because their treatment options are often more limited. So the way I did the string matching was to look at the triple negative and the estrogen receptor positive or progesterone receptor. Sometimes it's documented as PR versus spelling it out. HER2, for example, may or may not have the dash. They may say negative or they might just write negative there. So the approach was to break up the clinical notes into sentences and then just count the sentences that match. And then there was also an elimination string because we want to make sure that the note is talking about patient's cancer and not a family member's cancer. So I simply classified this using majority vote. However, if there was a mention of triple negative, that trumped the calculations. So we were able to answer questions based on this. Like, for example, we were able to look at the distribution of our whole population. So the size of square here denotes the size of the population of that particular cancer type. Like, for example, this here is our triple negative patients who have HER2 negative, ER negative, and PR negative type of cancer. So since I was doing this at patient level, I was able to answer questions like what is the age distribution of our triple negative patients, because I can combine my findings with other pieces in the data mart. How many triple negative patients are there in each provider's panel? This is important in terms of provider burden because caring for triple negative patient is different from caring for other types of patients. So these are the type of questions one can answer, and using these very simple tools, and that is kind of the point I'm trying to make here. Sometimes these kind of tools are enough. We did take a look at how good was this algorithm. So when our clinical partners were able to give us some bandwidth, thankfully, to actually abstract information for some patients, we looked at 37 patients and we found that our ER and HER2 extraction from our algorithm was about 95% accurate and PR piece was 92% accurate. So overall, roughly a 90+% accuracy. So then this was enough for our purposes. So one can do far more fancy things here. We can list ways in which we can improve this project. However, in this particular use case, this kind of accuracy was enough for us because we were not looking to decide individual patients' care based on this. We were trying to understand our panel. So let's look at second project, and this does use a little more updated kind of tool set. Let me set the context again. We know that healthcare regulation is very complex, right? So this is from American Hospital Association. Their report finds that American hospitals and healthcare systems must comply with 600 plus discrete regulatory requirements. And they spend a ton of money doing this, making sure that they are compliant, and they have to employ a lot of FTEs to ensure compliance. According to an author, Mr. Field, who has written a book on the topic, the pervasive nature of healthcare regulation stems from the fundamental concerns that are at stake. And this makes sense, right? Like, we do want healthcare industry to be regulated. If I visit a doctor, or if I'm admitted in a hospital, I derive comfort from knowing that there are laws that my doctor or my hospital is bound to follow. However, the present regulatory structure is neither uniform nor consistent. What it is complex, and that is where this project comes into picture. So we worked with our regulatory compliance team to identify relevant references from multiple sources. So let me show you the kind of tool that I built for them, and this is hosted on Hugging Face Spaces. So we have a regulations chat, and this is for Washington hospitals where I work. So there were documents that were handpicked by our team. So the way this works is some of the documents, like for example, this is a CMS document, Appendix A. This is a 500 plus pages document. Our hospitals must also comply with state regulation. So we look at RCWs, the Revised Code of Washington. So a whole bunch of these documents are RCWs. So what we can do is to ask a question here. So one can ask, like, how should expired medications be handled? And when you click this find excerpts, under the hood, my code will look at these different documents and find matching excerpts that help answer this question. So one can look at the CMS document as well as the RCWs. And this is a semantic search. So for example, here there are laws around drug samples. So drug samples which have exceeded the expiration date shall be physically separated from other drug samples. So these kind of rules, it is helpful for our regulatory compliance team to extract all this information quickly and easily. So under the hood, this uses retrieval augmented generation, and this is from deep learning source. So the way this is done is you feed it all these PDFs, which were handpicked by our team and which are available on the internet. I'm not providing any database here. So all these documents, they will be split into chunks. And these chunks, the embeddings are stored in the vector store, and then this is the piece that lives on Hugging Face for me for my code. The Hugging Face spaces is open, so you can actually go in there and play with the tool yourself. So this vector store, when a question comes in, it is matched with this vector store, and relevant splits are extracted. And in principle, one can, and I'm doing this under the hood, you can create a prompt that includes the relevant extracted information as well as the question, and that is fed to an LLM, and an answer is generated. However, often, again, keeping with our simple and practical theme, often even more than the answer, these relevant chunks in themselves are useful. So for our regulatory team, for example, a 90 or 95% accuracy is not good enough. They actually want to find the answers themselves, the value add for them here is to simply easily find the relevant pieces of information. So that is kind of what I'm displaying here. I'm displaying matching information, matching pieces of information, so that then they can find the pieces or the exact answer that they are looking for. So let's conclude the kind of projects that we are working on and we want to continue working on. So extract structured data from clinical notes to augment data marts. So the information that we are extracting from unstructured data, that can essentially be converted into structured pieces and fed back into the data marts, so that other members of our amazing team can then use it in their dashboards to slice and dice data in different ways. I'm working on using proprietary data. So like, for example, in addition to the regulatory data, there is also the external regulations like the CMS or the state regulations. There is also hospital policies that we want to comply with, which is proprietary data sometimes. There is patient level analysis. So this is PHI data. So we want to use LLMs, for example, to extract more complex information directly from clinical notes. So this field is just amazing right now to work in. And if you all are working on projects related to something like this, I would love to hear from you as well. The learnings have been teamwork is crucial for this. I'm blessed with an amazing team to work with. So working with other domain experts, they know so much about data and about how Epic works. It is really nice to talk to them and learn from them, as well as our clinicians and domain experts, because only together can we actually extract information and develop good projects. Our infrastructure team is also vital, because that is kind of the reason why I started with something that was already in the public domain, like the regulatory documents live on CMS and external websites. There is no protected information there, so I can host it on Hugging Face, which was the simplest thing to do. But in order to now use proprietary data and PHI protected data, everything has to be housed within our firewalls and still made available to our business partners in a way that doesn't put patient information at risk. So it's important to work with different teams. Part of this work is also the art of finding good problems to work on, and then using the right tools, simple as well as complex, depending on the problem at hand. And it's always fun to keep honing your toolkit and to keep learning, which is kind of why we are here. I hope something from what we talked about today resonated with you. And if it did, please do reach out. I would love to continue this conversation. Thank you very much.